Hello everybody and welcome to another session on Hello everybody and welcome to another session of Power BI Office Hour. Okay, so today we'll be doing something on Python, and today I'll be presenting on Introduction to Numpy. So my name is Ifeanyi Benedict and this will be my topic. So the Power BI learning community is being sponsored by let me check the sound.
You can go on.
All right. Okay. Sorry about that. So the Power BI learning community is being sponsored by Enterprise DNA. It's being sponsored by Enterprise. It's being sponsored by Enterprise DNA and being powered by UrBizEdge. Okay. So Enterprise DNA is a firm, and they are interested in empowering Power BI users to learn more about how to use Power BI, and recently also Power Platform. Then also again, I would like to wish you guys Happy New Year. Okay, so UrBizEdge is a registered Microsoft consulting and financial modeling, business intelligence, data analyst, and enterprise solution firm in Nigeria, and they specialize in helping companies and high professionals to bring on top of their business data. So my name is Ifeanyi Benedict Iheagwara, a business intelligence and data analyst at UrBizEdge. I'm also a Microsoft certified data analyst associate, and also a Microsoft certified trainer. So I'm skilled in Microsoft Excel, Power BI, SQL, and Python. Also a technical writer, and sometimes we make some content for UrBizEdge which you can check out on our YouTube channel. So I'll go straight to the topic. Okay, so today I'll be presenting on Numpy. I'll just give you a brief introduction to Numpy and all. Okay, so the first thing, if you have Anaconda, you can launch your Anaconda Navigator. From the Navigator, I will launch Jupyter Notebook. So I'll be using Jupyter Notebook today to demonstrate and to introduce you to Numpy. Okay, so when your Jupyter Notebook loads, all you have to do is look for the part of where your file is being saved or where you want to work on. Okay, all right. So today's agenda, I'll just give you a brief introduction to Numpy. So we'll be looking at what is Numpy. We'll be looking at the difference between Numpy and a list. We're looking at some Numpy operations before I move straight to some special functions in Numpy. Okay. Okay, so first of all, before we go straight to Numpy, so let's also know what Numpy is. Okay, so Numpy is basically means numeric and Python. So like this name says, numeric and Python. So all you can think about is just maths and numbers. That's all you do. So Numpy is a MATLAB replacement. It's also a backend and core component of Pandas library. If you're familiar with Pandas library, then also again, Numpy is also it's basically used for, like I mentioned, maths, numbers. It's also used for scientific computing. And Numpy comes with a lot of features. Some of the features has multi-dimensional array objects. It can also be used for, so you can work with arrays. You can also integrate it with C++. You can also use it for linear algebra. You can use it for random number capability. So NumPy really is very, very useful when it comes to data analysis. Okay. So before I go into the difference between NumPy and a list, first of all, let's look into how you can install and import NumPy. Okay, so I'm using Jupyter Notebook. So the thing with Jupyter Notebook is you can either write codes or you can write like text, like or you're saying numbers. So you click on this plus and gives you a cell. So here you can select whether you want to use it as a code or you want to write in a markdown language. So the first thing you do, we're going to install or import NumPy. So to install NumPy, for me myself, I just have to use a pip install NumPy and it will get installed on this notebook. But since I've already done that, all I have to just do is just import NumPy as np. Right. Okay, so with NumPy, so now I can start working with NumPy. Okay, so let's first of all look at, like I mentioned, let's look at the difference between NumPy and a list. Okay, so like I mentioned, NumPy is used for, you guys NumPy has this stuff called arrays, and arrays are basically data structures which consist of elements. So they're basically data structures, so which consists of elements. So to think of it as kind of like a list, basically, and which is like a list of numbers. That's an array. Array is just a list of something. So it's basically, but the proper definition is a data structure which consists of elements. Okay, so first of all, we'll look at NumPy. So let me first of all look at how you can create 1D arrays, and then we'll see how you can create a 2D array in NumPy. So first of all, let me create so I want to create a 1D array. Okay, so when I kept this asterisk sign, so in Markdown language, this means like kind of like I'm making a comment. If you're familiar with like just like you do in Power BI with the double slash, it's the exact same to with Python. Here is a asterisk instead of a double slash. Okay, so I'm creating an array. So to create an array in using NumPy, so you just do np. The np here signifies NumPy. So instead of me writing NumPy, I can replace I can use np as to just calling NumPy. So np dot array, then you use your double bracket and you use this, I don't know what it was technically called, uses this other kind of bracket, and you give it a list of numbers. So let's use 1, 2, 3. Okay. So yeah, if now I want to call this, all I have to do is like call a. So if I use a print bracket a, which is 1, 2, 3. So this is a 1D array. So this is what we call a 1D array. Okay, so now let me try creating a 2D array. So let me create a 2D array. And if you notice, this is just like, it's just a structure which consists of different elements. So basically that's an array. So you do b again. Let me do np dot array, the bracket. Then now I'll open this other bracket again. So let me do like a 1.0, 2.0, 3.0. Then now I'll put a comma and I'll open the bracket. Then this is going to be 4.0, 5.0, 6.0. What did I do? Clear it. Yeah, my mistake. Okay, so yeah, this is a 2D array. So a 2D array, think of a 2D array like you can learn like a bus. So a 1D array is just like a roll, move like a roll. Just think of a bus. A bus is square corner. So a 1D array is more like just a roll. A 2D array gives you rows and columns. So like this now, I can bring this down. So this like one row, this another one, and this one column. So now, so if you want to call it again, I use the print function and I print in my lesson. So now let's look at the difference between, like I mentioned, what's the difference between NumPy and a list, because this just looks just like a regular Python list. But so what's the difference? So the difference between NumPy and a list, or why most time a NumPy array will be preferred over a list, because of basically 3 different reasons. So NumPy it consumes less memory. It's also fast and it's also more convenient to use. Okay, so what I mean by consume less memory. So like now, let me show you what I mean. So I do an import time and also import this function. Okay, so I do a now equals to, let me use the range from the range function. So the range function just gives me, I'm just letting to give me a range of number between this, does give me this entire number. So I use maybe 1000 as my range now. So now let me print dot. I want to use the get size function. So this is a list. This is me, a regular Python list of this now. Then let me multiply this by the len. So len is to get the number of in a cell in it's the memory size of this list. Now if I try to create this exact same thing now using also again with using NumPy, you see I'll get a lower memory size compared to if I have used the list to do this. So now let me use a B. So for NumPy, you don't use. So I'm not using NumPy, so I'm using functions other than NumPy. You can learn more about NumPy by visiting the documentation. So because I'll only be showing you a few handful of the functions available. So you can just visit documentation and you can learn a bit more maybe about NumPy. So now we're back to this. So I use b equals to, I use the arrange function. This is just like the same thing, the same 1000. Then here now I'm going to do a print, and again times, let me say size. So the size is just like we use same to like limited as a Python get size of. This is NumPy's version of it. Again multiply by again, which is similar to the len. This consumes way less memory compared to when I use the Python list. So that's the reason why NumPy is faster, consumes way less memory, and it's also very convenient and very easy to use. As we continue going, you see how easy and convenient NumPy is. Okay, so um okay so I've looked at what is NumPy. Now you should understand the difference between NumPy and a list. What makes NumPy better than a list? Like I mentioned, the difference between or one making NumPy better than a list is just 3 simple reasons. It consumes less memory. Fast. And it's also very pretty convenient. So now let's move to the third algebra for today, which is Numpy operators. So your Numpy operators are similar to your Excel, your Power BI. So here we're looking at how to get the data type of our list, how to get how to get the data type, how to get the size, how to get the dimension, and a few other stuff. So when I talk about Numpy operators, here I'm just looking more into the dimension of my Numpy array. What is the byte size, which also does do with the memory. Well, I've looked at this, which is to do this is usually going to use the size, the item size formula, or the exercise function. Sorry. Then again, we're also going to look at how you can get the data types of or array. Okay. So again, let me create a new Numpy list. So let me use the same np dot array and 1, 2, 3. Okay. So now I want to get the dimension of my Numpy array. So get the dimension of my Numpy array. You just use you call your array and use the .ndim function. So it just means one dimension. Like I mentioned, this how to create a 1D array, one dimension array. Then next was the byte size of our array, which is the size. We have used or looked at something similar to this when we're trying to compare the difference between Numpy and the list here. So we use this item size formula. So dot equals to dot item size is 4. So the item size of this array is equals to 4. So next we'll look at the size. So the size, what it does is gives you like how many elements is in the list, is in the array. So this is different between the size. So the item size is more of the memory size, the byte size. This size is more about how many elements. So you just use a dot here, dot size. It gives me 3. It's 1, 2, 3. Okay. So next we'll also look at the shape of our array. So we'll do dot shape. And this is again 3. So the 3, I'll come to this when I go into indexing, and so this also does do with this comma, this is like the rows and then the columns. I'll explain more details when we get to indexing. Okay. Now let's repeat the same thing, but let's use a 2D array for this. So you have B. Again, let me create a 2D array equals to, you can keep it like this, but I like using space because of readability. It looks easier, it feels easier on the eyes when your codes are a bit spaced out. The same thing, you open the first bracket, then I open this bracket, and open this now. So let me use 1.0, the same thing, 2.0, 3.0. You open this now. You use maybe 0, 5.0, 6.0. And now let's print B. Okay. So we're just going to repeat the same functions I've used there, but let's look at what it's going to show if we're using a 2D array. So the first time I mentioned, look for the dimension. To look for the dimension, use .ndim. It tells me to because it's a two-dimensional array. The next thing I use is b dot shape. This is 2 by 3. So the 2 here means, like I mentioned, it's 2 by 3. 2, then 3. Then, so it's 2, as in there are 2, then 3, as in there are 3 elements. Then the next again we use b dot shape. Okay, let's use b dot shape, b by size. So it's 6. So like I mentioned, the size tells you more about how many elements are in it. And the next thing, let's find out the memory or the byte size, which is our item size, which is tells us is 8. Okay. If you want to get the, so like I mentioned, you can also find the data types. So let's look at data types. Okay, so the data types will do b dot the type. This is an in. So like I said, O number. So ins are similar to in, which is integers. They are like your own numbers. So if you're familiar with Excel, you add numbers, text, brain, and the rest. So numbers, there are two types. We have either that it's an O number, which is this in, or this this then float, which are more like decimals. So if I use b here dot the type, I got this a float because, like I mentioned, this is 1.0, 2.0, 3.0. This was just 1, 2, 3. So this was an odd number, but this was a decimal. So this is a float, and this is an odd number or an integer. Okay, so this is an integer, and this here was your float. And that's also like your decimals. All right. So these are your. Okay. So now we're going to move into slicing and indexing. So slicing and indexing is more like extraction. You're trying to get an entire list, but you only want to extract just some few. You don't extract every single element on the array. In the array, you just want to get some particular elements in the array. So let me just write this down. Indexing. Okay. So let me refresh my mind by calling back. Just how our B looks like. Okay. So if now from this B I want to extract let me say I want to extract number 3. So you would also call B and then you call it. So if you put doing Python is numbers. So whenever you're doing counting numbers, you count 1, 2, 3, 4, 5. However, in Python, the numbers are counted. Numbers start counting from 0. So this is more going to be more like, so here you put. So here you're saying you call this like row 1, row 2, but this is more like row 0 and row 1. Okay. So if you want to extract 3, I'm going to set down get from row 0, comma. Here it's not going to be 0, 1, 2, so more like 2. So that's sliding. This was because it's where I'm trying to extract the number 3.0. Okay. So let me try extracting. Let's see how do you think we can extract number 5.0? Extract number 5.0. So anybody? So extract 5.0, we use the same thing. How is B? You open the brackets. Okay, 1, 1. Yes, so to extract 5.0, yes, it's going to be 1, 1. Yes, so this 1, so that you want this row, sorry, you want this row. So you got it on row that you do comma, you want the second, technically for us, is the second element, but to Python, that's the first element in that row. Comma on, correct. That's correct. Okay, so if you want to, so you know, while I was trying to extract number 3, I wrote this. Another way of doing this would have been, I use B, I use 0, comma, -1. So the -1 is more like I'm counting now from the bank. And if you're counting from the bank, there's no -0. So there is just like normal. It's just like how we count normally. So here it's going to be -1, -2, -3. So now to get this 5 here, somebody else could have also written again 1, comma, -2. Okay, so this is the basics of slicing and indexing. You can also extract a complete role in this thing. You want to extract a complete role. You can also do that. So this is also to be this comma equals 0. So this extracted the first column, so which is column 0. So extracts the first row. So like I mentioned, this is more like a role listing. Role and column. So here it extracted the first row because we kept this dot means you want similar to when you're doing Excel and trying to get an entire column and you do like A to A. So like one from the beginning to the end. So it gives you the beginning to the end. Okay. But in which particular column? You said column 0, which is this. So from the beginning of column 0 to the end of column 0. Why this? Let me call B here again so that we don't have to always be going up and down. Okay, so why here B? Why here we did, we wanted row 0, which is the very first row, and we want from the beginning to the column to this end of that row, from the beginning of that row to the end of that row. So it is 0, comma, dot. Okay. So there's also another function in Python, which is it's called the line space. So the line space gives you, if you remember where I started, I mentioned that Python gives you random number capability. We'll look more into that later. So to get random numbers, so this line space will give you equally spaced numbers based on what you give it. That's what I mean. So now I do maybe like A equals to, I use np dot line space. I close the brackets and I do maybe 1. So I want from 1 to 5 and 10. Okay, I made a mistake in my spelling. There's no E. So now I print. So it gave me 10. So give me 10 elements here. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's spaced equally by 5. This plus this will give you 5. By go to space. It's going to space equally. Okay. And again, it's also going to be between 1 and 5. Between 1 and 5. So that's the line space. Okay. So far, we're getting it. Okay. So okay. So first of all, if I move to a different topic, let me first look at how we're doing maybe like it was a 3D array. So for a 3D array of AB, so let's just see. Okay, so it goes to np dot array. First we'll call this bracket. This. Then so we 1, 2, 3, 4, 5, 6. So this is opened. It's closed. So this will be 7, 8, 9. Here. So it is more like a 3D arrays. Just remember that I didn't show how to create a 3D array. Okay, so now let's move into a different topic. We'll be looking at transposition and reshaping, how you can reshape your array and all. Okay, so reshaping arrays. So loss is array number D. So use np dot again dot array. We'll create a this, then you open this. So now loss we have so now I want to reshape this array. So let's also get the current shape. So what is English shape? So this shape is going to be more of a 2x4, like 2 rows, then 4 columns. So D dot shape, yeah, so it's a 2x4. There are 2 rows, there are 4 columns. Okay, so I want to reshape this into a 4x2. So the number reshaping is, even when you're reshaping your arrays, you have to reshape in a way that is also what I put this, mathematically possible. So I can want to reshape this into maybe 3 by 6, because the numbers are not going to be enough to occupy 3 by 6. Okay. Like I can reshape this into maybe a 1 by 4, so 1 by 8. Yes, but you can't reshape it so something that the numbers available or the elements available are not, it's not going to make up what you want. So to reshape this array, just do dot reshape. Let me call it into something else. You see DE equals to reshape. Then you measure the shape you want. So I want a 4x2. And now I create E. There's a 4x2 now. So 4x2 as in there are 4 rows, and 2 columns. That's what that means. You can't say you want to reshape this again into something that is mathematically possible. Then let me start to shape is a 3 by 6. So that's it. Okay. So now let's look at, we're staying on Numpy operations. So for Numpy operations, we've looked at how to find out the dimension, the byte size, the data types. We've looked at how we can slice and index our NumPy array. We have seen how we can reshape our array. So now we want to look at how can we stack our arrays. So let's look at stacking. Okay, so you can stack your array vertically or horizontally. So there's vertical stacking. There's also horizontal stacking for arrays. So to create one by one, another one by one. So we I don't think I really need to print it. I think by now we should be getting the idea. So if you want to stack your array vertical, all you have to do is also numpy is np and vstack. So you want to stack array A and array B. So now the one wants to go ahead and stack vertically, which is on top. You can also stack your array horizontally. Horizontal. So here it does the np dot stack. So close the brackets, open this. Now it's just vertically. So now together. Go like merging. Okay. You can also do, there's also another function to also do this. This by using the array VL. Okay. Okay, so let's look at, now let's go into special functions in array. So by special functions, I mean we're looking more at statistics. So doing mathematics, like I mentioned, arrays for basically means numerical Python, and it's also for scientific computing. So yes, where's the maths? Where's the maths? Okay, so you do so the max, which it's array functions. Okay, right. So array functions, we already know our maths. So we have either you're summing, you're subtracting, you're multiplying, you're dividing. So you can do all that in Python. So first of all, look at how does it look like when you're doing it with a 1D array, and then we'll see how we're going to do it if you are using there are two arrays here. So use two arrays how to go. So let's go back our A 1 to 3. Okay. So if we do A plus 1, so you just added the 1 into every single element in this array. So the same thing that also happened, you do a minus 1. You just subtract 1 from every single element in the array. So today divide is A divided by A divided by 2, and A multiplied by 5. And multiplies every single element available in this array by 5. Okay, so now, if you remember initially, or a few minutes ago, we had two arrays, two 1D arrays. So we had one A and B. Okay, so now once you also use this match functions on between arrays. So when you use it, it's more of, it does it kind of like a matrix. It's kind of like a matrix level addition and subtraction. That's what exactly happens. If this is also another reason why NumPy is also better than, why not better than, but why NumPy is maybe seen as convenient and faster and less memory. So one of the conveniences, if I was going to do this, this were two lists, you might probably have to use a loop to do this, but with the numerical or using NumPy, you can just do this straight up. Okay, so C is equals to so what it is now, I multiplied array A and array B together, so it multiplied every element together. If it was a division, maybe this divided by this, and you get this. Here it was this. So it does, like I mentioned, it does more of like on a matrix level. This, okay, right. So now let's look at other statistical functions that we're familiar with. So these other functions we're going to be looking at our how you can calculate your mean, stroke max, even your square roots. And the rest. Even again, also show you something on the sum. That is the sum function. Okay, right. Okay, so let me call A again to this. If you want to get the mass, how does do A? It's mean. And call A. This is the minimum number or the minimum element in this array. You guys do np dot max. But yeah, let me call B. So let me call B here. Okay, so this is the maximum number in this array. So now to calculate the square root, if you did an np dot sqrt square root of B, see it took the square of literally every element. So square root of 4 is 2, and the others are floats. Okay, so now let's look at the sum. Okay, so first of all, let me create a new array. np.array. Okay, I mentioned you open this. You should put them, and now you are writing them individually. So here we have a 1, 2, 3, 4. Then 5, 6, 7, 8. Okay. So when you're doing the sum, you guys use some function for this also. So I'll show you the sum. So if I do np dot sum and I call C, that ups every element here. Essentially, if I was doing it for my A here, you'd have added every element here. So every 1 is 3 is 6. So np dot sum. then A, 6. Okay, but I created this array to show you how you can do sum. So you can do sum. You can use some formula on kind of like on an axis level. So there are two axes. So you have axis 0 and axis 1. So your axis 0 is like your row. So looking for a box. Okay, so you have seen this box now. So this is going to be this axis 1, which is your row, and axis 0, which is your column. So this is axis 0, this axis 1. So if I come here now and I do a, let me say, this using axis 0 equals to, then I do an np.sum, trying to use for C, comma, as this equals to 0. And here as is 1, d equals to np.sum. The same thing again, C, comma, as is equals to 1. So this as is equal 1 is okay. Let's see if I can find. Okay, so just like you Excel, every inside the formulas, there are also some optionals in Python. So you say your functions, there are also some optionals. So this one of the optionals by default it gives you this error, but you can specify that you want to do it in a column wise way. So now if I print 0 and I print is 1, you still get 2 different cents. So let me print again. Okay. Guess what I want to do. Okay, so this is our initial listen. 1, 2, 3, 4, 5 to 8. So axis 1 gave you us on a column wise way. So it's adding everything in this column together, everything in this column, everything in this column, everything in this column. But the axis 1 gives us on a row way. So you added everything on this row as 1 and everything on this other row as the second element in this array. So that's the arrays of using that's array of the sum. That's how to use the axis. Okay, so the last topic we're going to be looking at is going to look at some special functions in array, or we can say array processing. Okay, so there are some special functions in array. You can use like the dot zero. There's also the dot ones, dot identity, dot full, and we also look at the random capability of Numpy. Okay, so first of all, you have np dot ones. Where you do is so you just give it what you want. Do you want it 2 by 2? Do you want just so you want to so you can ones, but now it gives me the ones in a 2 by 2. You can also do an np dot zeros again, comma 2 by 2s. This will give me 0, 0, 0, zeros. Then then the other one just have the identity. Let's call it a. So it gives me 4 rows, 4 columns, and from the column list, the diagonal list, all the numbers there will be ones. So you also, besides giving it that you 1 1s, 2 2 0 0s, you can also tell it to give you like 2 2s. So you can use np dot. Let's use np dot full. And here you inside here you give it just like what I'm doing here. So want it 2 by 2. Then one number you want, maybe 2. You get 2. If you repeated this, the 6 or a 7, you get this. Okay, so let's just briefly look at the random capability of Numpy. That's front. But you can also do np dot random. Then you want to do a rand. So the rand is like your extra function. So if you remember, the rand function gives you random decimals. So this also gives you random decimals. So that's why I said this. So want a, let's do a 2 2. This. Where I repeated the exact same function, I'll get totally different from what I got. So it just randomly gives you random number based on whatever you want. So this is for random decimals. Let's look out for random, maybe integers. So this you can use the dot rand, and there you specify you want rand int. Just you open the brackets, you say the numbers, sorry, then use the size. This was just like plain. So nice. I've done the same thing. Let me use the 10 here. What do I? Okay, so 10. So the very last topic we'll be looking at now is how to copy your arrays. Okay, so if you recall in so if I'm trying to copy that array 1, array 2, that is. So if you remember, the A I had was this was my array A. Okay, so I want to copy this array. If I do a B now equals to A, this has given me this, but this has also changed well the B that I wanted. If you want a better way of copying or a better way of copying your arrays would have been a let me just now C. So equals to or the A dot copy and close the bracket. So this is a much better way because once you when you're going a bit advanced like formulas, you run into a bit of problem when you do something straight up like this. So this is just a quick random run through of NumPy, and that's all I have to say. So are there any questions so far? Or any questions? Any part that wasn't clear? Okay, in the absence of any questions, are there any questions? Okay, so in the sort of any questions, I hope with this you're able to understand and able to understand a bit about NumPy. Why is NumPy, the difference between NumPy and the lists, how to operate, how to do some basic or some simple operations using NumPy and some NumPy special functions. So, yes, next week.